Hi there. Thank you for clicking on this video. In this short video, I wanted to talk about the two main categories of real numbers. Now, for the sake of this discussion, we are going to define real numbers as numbers that we can find on the number line. If you picture your number line with the 0 in the middle, and you've got your positive numbers going off to the right and your negative numbers going off to the left. If you can find a number on this number line anywhere, it is a real number. So positive numbers like the number 2 is real. Negative numbers like -3 is real. 0 is real. A lot of times students are like, oh, 0, that's not real. Yes, it is. If it is 0.5, it is real. Okay, so if you can find the number anywhere on the number line, it is a real number. Real numbers are divided into two categories. Now there's subcategories of these that you'll hear, but we're going to focus on like every real number falls into one of these two main categories. One is it could be rational. That means it can be written as a fraction. So in the word rational, kind of focus on ratio. So I could write it as a ratio. So this would include things like integers. So say the number 3 is not written as a fraction, but I could write it as a fraction. I could write it as 3/1 or 6/2. Anything that's already written as a fraction, like -1/2, that's clearly rational because there's the fraction. Now, decimals that end, so the number 1.5 could be written as 3/2, or a number that repeats, so 0.33333333333, like so we get a repeating decimal, that would be the fraction 1/3. So if it can be written as a fraction, it is a rational number. So the other category is the irrational numbers, and the prefix IR means to negate. So irrational means not rational, and these are numbers that cannot be written as a fraction. And sometimes you might hear those defined as non-terminating, that means non-ending, and non-repeating decimals. So examples of irrational numbers might be the number pi, 3.14159, and that decimal keeps going on forever, and it never ends and it never repeats. And most of your square roots are going to be irrational numbers. So if it's not a perfect square, it actually will end up being irrational. Now, proving that they are irrational. So how do you prove that there's no fraction out there at all anywhere that would be equal to the square root of 2? That is something for probably a college level math class where you would actually try to show that, like, how do I know this decimal never ends and never repeats? And it can be proven, but that is beyond the scope of a 3-minute video. So I hope that this video helps clarify the difference between rational and irrational numbers and how our real numbers are broken into those categories.